we're going to solve a system of equations. This is only a 2x2 system of equations. And I'll bet you could do this pretty easily without knowing anything about matrices. But the reason I'm going to use Cramer's rule for this, which is clearly over the top, is that I think it's a nice demonstration of Cramer's rule using something simple. So you see, the first thing we're asked for is to convert this into matrix form, right? I have the coefficient matrix here. I have my solution matrix there. And what I'm going to need is two more matrices. See, one of them is this thing called AX. And I'll show you the way that's coming about. If you take the solution matrix, 1, negative 2, or negative 1, negative 2, and you substitute that in here into the first column of the coefficient matrix, that creates AX. And likewise, if you take the solution matrix, negative 1, negative 2, you substitute it into the right column of the coefficient matrix, that brings you down here, and we get AY. So you should know how to construct these two new matrices, AX and AY. And those are going to be very important because we need to calculate three sets of determinants, as you can see right over here on the left. I want the determinants of all of these things. So let's start with the original matrix A. Determinant of this, which I hope you remember is just a butterfly pattern. Let me clear some of this stuff out of the way so I can work. This is just a butterfly pattern of going like that. Okay? So determinant of A is going to be negative 3 times 5 minus 4 times negative 5. Oh, let's combine some terms here. This is negative 5 minus negative 20, so that's plus 20. Great. So the determinant of A is 5. Okay, next one, we'll do the AX matrix determinant. That's going to be negative 1 times 5 minus negative 2 times negative 5. So work through all those minus signs. Really be careful at this point because mistakes are not great when you're working with matrices. This is going to be negative 5 minus 10. So that'll be negative 15. And the last one, same process. The determinant of AY equals negative 3 times negative 2 minus 4 times negative 1. Okay, and that equals 6 minus negative 4, so that's 6 plus 4. That is 10. Okay, we have all these determinants, and here's where Cramer's rule comes in very handy. To solve for x, here's the equation. The determinant of AX divided by the determinant of A, which, as you can see from what we did earlier, that's just going to be negative 15 divided by 5. So that's negative 3. And that's our solution for x. For y, it's going to be AY, the determinant of AY divided by the determinant of A, which is 10 divided by 5, which is 2. There we go. That's Cramer's rule. When the system gets bigger, and I'll do one of those examples too, you simply have a few more matrices to determine, and then you run these same formulas at the end.